Hello and welcome to Jocelyn and Danielle's Gas Labs video. We have decided to complete the can lab and the marshmallows and balloon lab. Let's start with the can lab. The question is, does the can collapse or expand? Our hypothesis is, we believe that the can will collapse upon contact with the cold water because of the sudden temperature change. This is due to the molecules in the can ceasing to continue to move as quickly as they were at a high temperature, thus creating a partial vacuum. The materials needed are water, a hot plate, ice cubes, clean and empty soft drink can, oven mitts or tongs, and an ice water container. As shown in the video right now, I'm pouring about 10 milliliters of water into the soft drink can, and I am about to put it on the hot plate. You heat the soft drink can on high until most of the water has boiled out, and this should only take a couple of minutes. And during this time, we could see the gases escaping from the can due to the boiling of the water. And now, you can see that the can collapsed upon contact with the ice water. When the can was placed in the water, the can collapsed. This was exactly what we predicted would happen. A partial vacuum was created, thus sucking the can in on itself. When the can is taken from the water, it is the same temperature as the water and has an equal amount of pressure as the atmospheric pressure of the room. Volume is directly proportional to temperature, meaning when temperature increases, volume increases, and when temperature decreases, volume decreases. This is also Charles' law. This particular lab uses Charles' law, which states that the volume is directly proportional to temperature. As temperature increases, the molecules within the can begin to increase in speed, thus causing an increase in volume. Three sources of error are not placing the can whole first in the ice water, not heating the can enough, and not putting enough water in the can. Through observing the outcome of this lab, we have concluded that when a container, the can, is heated, it causes the molecules to increase in speed, thus causing the volume to increase. Yet, when it goes through a sudden cooling, the molecules will decrease in speed so quickly that it will create a partial vacuum and collapse. This goes hand in hand with Charles' law, V1 over T1 equals V2 over T2. So the next lab is the balloon and marshmallows lab. Our question is, how do balloons and marshmallows behave in a vacuum? Hypothesis: we believe that the marshmallow will shrivel up and the balloon will pop. This is because the vacuum will suck up the air from both objects, causing them to decrease in volume and air pressure. Materials needed is a vacuum chamber with a pump, balloon, and marshmallow. Sadly, we forgot to take any videos or pictures of us doing this lab, so we'll be using pictures from the internet, and I will link 2 videos below. When the pump was turned on, the balloon began to expand until its volume almost matched the volume of the vacuum. When the vacuum was switched off, however, the balloon returned to its original size. With the marshmallow, when the pump was turned on, the marshmallow expanded to almost twice its size/volume. Unlike the balloon, rather than the marshmallow returning to its original size after the chamber was turned off, it shriveled up. Along with this, gases were seen escaping the marshmallow at the time of expansion. Both objects expanded when the pump was turned on. When we turned the pump off, the objects began to slowly regain their original shape and then continued to lose air. Our prediction was incorrect. Instead of losing air as we predicted, the balloon and the marshmallow gained air and expanded. The air within the chamber is being sucked out by the vacuum, causing the external pressure to decrease around both the marshmallow and the balloon. This causes the volume to increase due to the fact that the molecules within these objects have an increase of space between them and do not collide with each other as often as they would with a lower volume. We believe that the balloon would have the same mass before and after the experiment. The mass of the balloon is calculated by the mass of the balloon itself. Example, the material. Because none of the balloon's material was lost or gained during the experiment, the mass remains the same. The same goes for the marshmallow. No amount of mass of marshmallow was lost or gained during the experiment. Therefore, the mass remains the same. The air molecules within each of these substances are growing farther away from each other due to the increase in external pressure around both objects. The air molecules begin to collide with each other less and less, causing the volume to increase and the balloon and marshmallow to expand. Boyle's law states that volume of a fixed amount of gas at a constant temperature is inversely proportional to the external pressure on the gas at a constant temperature, due to the fact that the vacuum is decreasing the external pressure on both the balloon and the marshmallow. The volumes of each increase. Because there was no change in temperature, we know that the object's change in shape can be explained using Boyle's law. Three sources of error are the possible hole in the balloon that could have caused reduced expansion, possible error in switch placement, example is turning a switch the wrong way, or not placing the hole cover/holder above the hole, causing the balloon to be sucked into the hole. When balloons and marshmallows are placed in a vacuum chamber and the pump is switched on, both objects expand in volume. The molecules within these objects spread farther apart, increasing the volume. This is due to Boyle's law. So thank you. I hope you enjoyed our gas labs and have a wonderful day.